Okay, it's amazing to have you here today. We are looking at this project 0 times 1b sortie algorithm and big O in C programming language. Okay, so before we dive right, let me explain that it's going to be more like a series of some videos to cover it all because it's quite a complex project. So we explain some of the concept first. Then I have a video that I'll link a video that will talk about one type of insertion, one type of sorting algorithm is going to help you understand the concept. Then we will dive right into solving the task later. Okay, so I believe that we are going to learn from what we are going to do, and in solving the task, I will explain what you need to know before we dive right in. Okay, this is it. I believe you should take your time anyway to look through the resources provided. Okay, basically, yeah, just take your time and try and grasp what you can from this video because it's going to help. Sorting algorithm, what are they? First, we have to look at what sorting is. By the way, sorting is the process of putting things in order. It could be rearranging numbers, words, or any other type of data to make it easier to for you to actually get what you want. Okay, so that's sorting. And basically, sorting algorithm is an algorithm that arrange a list of elements in a specific order, in a pattern. It have a pattern for arranging such element. Okay, we look into the type of sorting algorithm later. I just want you to pay attention to big O notation. What is a big O notation, or what are big O notation? Big O notation is a metric for determining the efficiency of an algorithm. How do we mean by that? Basically, we could say it measures how the performance of your algorithm will change as the input size grows. So input size, and some factors are dependent on how you use this algorithm. It does not tell exactly how fast the algorithm is going to run, right? But it does provide a way to estimate how long the code will run on different set of input. Okay, so basically you should know that the O in big O stand for order of, which represent the worst case scenario or upper bound. You should know that we have the best case scenario, we have the worst case scenario, time complexity. So these things are very important for you to take note of in understanding what we are talking about. And big O notation describe the complexity of your code using algorithm terms. I know these words are big, but I'll try my best to have a series of explanatory videos to back what we are talking up. Is going to help you to understand this concept really, because that's the aim of this video. Okay, so types of sorting algorithm. Here I looked at some of them, like we have here. You could we have quick sort, insertion sort, bubble sort, heap. There are so many of them counting, and if you look through those materials, you see them: heap sort, intro sort, merge sort, tree sort, block sort, and so many of the sorting algorithm. So many of them. And you ask, by the way, what's an algorithm? It look like a big term, right? But an algorithm is a set of step-by-step instruction that you can follow, or the computer can follow, to solve a specific problem. That's basically what an algorithm is: a step-by-step instruction, basic instruction that you go with to get this done. You can have an algorithm on how to cook your soup or make rice, and so on and so forth. So the way a pattern of sorting data, in different formats, is the algorithm that's in it. So we can have the insertion sort algorithm, which is a type of sorting, right? We can have merge sort, counting sort, bubble sort, smooth sort, and the rest of them. So this is also, take your time to go through this because it's going to help what we are talking about. Okay, so again, of course, you should know that you have a readme file, and some of these things are important. And for the quiz, I have a video on the quiz. It's quite lengthy. I think up to 42 questions on the quiz. So I'll leave the link, okay, of that. I have a video on that. I'll leave the link for you to go through that. It's quite lengthy. I can't show it all now. So basically, you know that you have a, what's it called, a repository. You create a repo. It's on, you create a repo, the sorting algorithm repo, then you create that on GitHub before you start working on this. So I'm going to show you what sorting basically is talking about, using a type of sort. So it's just a way of ordering items, of ordering data, of ordering numbers from, if you have a series of data, you sort them in ascending order from the lowest to the highest. All right, so that's what insertion sort is talking about. So I'm going to show you how the insertion sort work before we continue in the next video. All right, hey guys, we are looking at sorting, and in sorting we are looking at the insertion sort today. It's more like a series of videos we are going to do on sorting. Okay, this is more like a type of sorting algorithm. So we look at what sorting algorithm, what insertion sort is, and we take a look at algorithm. Then we give, an example of how you can sort an algorithm, okay, using insertion. Basically, by insertion sort, we are talking about a sorting algorithm, and by algorithm I mean just a method or a stepwise process of accomplishing a task, right? So by insertion is a sorting algorithm that works by taking one element at a time from an unsorted list and inserting it into its correct position within a sorting list. More like, see it as a way of rearranging items, reposition them so that they follow a pattern, a particular pattern, more like an ascending order from your number 1 to 10, or descending order from your numbers 10 to 1. So either way, you are sorting the items. And talking about algorithm, basically when we talk about algorithm, we are talking about a set of stepwise instruction, or that a computer follow, or a stepwise instruction of doing things generally that follow a particular pattern, and the aim of that is to solve a problem or accomplish a task, basically. So algorithm is a process or method of doing sorting, more like a method of doing it. All right, and again, know that a program is an implementation of an algorithm. And once I have an algorithm, I can implement it in any of the programming languages such as Java, Python, C, PHP, and the rest of the programming language that you are familiar with. So let's just have a list of items. So I'm going to come down here. We have a list of items, so numbers rather. The first one is 9. The second one is 3. The next one is 1. I have 4. I have 7. I have 5. Right? So our job now is we are going to sort this list using the insertion sort method or algorithm. Okay, so how do we do that? Basically, how we are going to do this, we want to rearrange this item by sorting them. So we compare each item to one another. So we go from one element or from one number to the other, comparing them, and we want to compare them to the element to the left. Okay, so if I'm sorting the first item, the first index, which is 3, this is 0 index, 9 is 0. If I'm sorting the first index, which is 3, I want to compare it to 9, which is the first element. I can't sort 9 because there is no element before 9. So take note of that. So let's begin this sort. Okay, so to do this, I'll just have to compare 3 to every other element before it. So we are sorting 3. Take note of that. So here, what will we do? We want to compare 3 to 9, and we ask the simple question: is 3 greater than, is 3 less than 9? Is 3 less than 9? If it is, then we put 3 in place of 9 and put 9 in place of 3. Just a simple pattern, a simple method. So is 3 greater than 9? Really, of course 3 is greater than 9. So in place of 3, I'm going to put 9, and in place of 9, I'm going to put what? I'm going to put 3. All right, so I have sorted that. All right, so I'll now have to rearrange this item. So what I'm going to have now, the first one will now be 3, the next one will be 9, the next one is 1, the next is 4, 7, and 5. All right, so after we have this, then we go ahead to sort the next item. We have sorted 3, we want to sort 1. Okay, we want to sort 1. So I'll just come here and do this here. How do we do that? Again, we come here and compare 1 to the element before 1, and the element is 9. So you ask yourself, is 1 less than 9? Of course 1 is less than 9. So what I'm going to do here is that I want to put 9 in place of 1 and put 1 in place of 9. Again, we are not done with that yet. Again, you compare 1 to the item before it. Is 1 less than 3? Of course 1 is less than 3. So what I want to do here, I want to put 3 in place of 1, and again put 1 in place of 3. So that has been sorted. So again, I come here, I rearrange my item. Now I have 1, 3, just like this: 9, 4, 7, 5. So this is what I have now. This is my list. This is my list now. So I have sorted these items already. All right, so the next item I want to sort now is 4. So I'll come here, I'll put 4 here. Again, I compare 4 to the item before it, which is 9. If is 4 less than 9? Of course 4 is less than 9. So what I want to do here, I want to put 9 in place of 4 and put 4 in place of 9. So again, I compare 4 to the item before it. 4, 3, is 4 less than 3? Of course not. 4 is not less than 3 or 1. So again, I rearrange my list. I have 1, 3, 4, 9, 7, and 5. So we have sorted our list up to this point. The next number we want to sort now is 7. So we want to sort 7 at this point. So again, let's do this. 7. We compare 7 to the item before it, which is 9. Is 7 less than 9? Of course 7 is less than 9. So what we want to do, we want to put 9 in place of 7 and put 7 in place of 9. So again, is 7 less than 4? Of course not. 3? Of course not. 1? Of course not. So that has been sorted. So we go ahead to rearrange our list. So after that sorting, we will have this. Our list will look like, we now have 1, 3, 4, 7, 9, and 5. All right, so that is what it looks like now. Again, we have sorted up to this point. Every element up to this point have been sorted. We have 5 left. So let's do that quickly. So we ask ourselves, is 5 less than 9? Of course 5 is less than 9. So in place of 5, I put 9, and in place of 9, I put 5. Again, I have 5 here, I have 7. Is 5 less than 7? Of course 5 is less than 7. So It's in place of 5 here, I put 7, and in place of 7, I put 5. Believe you understand this. Is 5 less than 4? No. Is 5 less than 3? No. Is 5 less? So we are done with that. So we go ahead to rearrange this list.